Right, so let's have a look at question 3 now. So straight away it looks like a recurrence relation question because we've got the subscripts on the VNs. So let's have a look at what we've actually got to answer. So the number of visits to a website in any particular month is modelled as the number of visits received in the previous month plus k times the number of visits received in the month before that. Okay, some constant. Given that Vn is what it is in month end, so this will be figure it as Vn. Right now, general recurrence relation between these. So because these are the previous months, this is going to be our Vn plus 2. So Vn plus 2 is simply going to be number of visits received in the previous month. That's going to be Vn plus 1, that's the month before it, plus k times the month before that, Vn. That's it, that's that one marker done. Now it looks like, show that Vn is equal to something that's not got Vn's in. That's going to be solving it, so we're going to think about how we're going to do that. So for a particular website, we are given that k is 0.24. So our equation now is Vn plus 2 is Vn plus 1 plus 0.24 Vn. Month 1, there were 65 visits. So that means V1 is 65. And month 2, there are 71 visits. So that means V2 is 71. Show that Vn is equal to that, and then we've got to solve something using that. So, version part A above, I'll just scroll it down for you there. So Vn plus 2 is Vn plus 1 plus k Vn. Notice not put 0.24 because I'm not giving information just at that point. And now we're going to put in the 0.24 here. And now we're going to have to solve the equation that we've got. So, in terms of a quadratic, we're looking, so you could do the substitution r to the n. So here we're going to have r to the n plus 2 is r to the n plus 1 plus 0.24 r to the n, which you could just divide everything by r to the n and you get r squared is r plus 0.24. You could just jump straight from here to that, that's absolutely no problem. If you've done, well, it's basically very similar to what we do when we do differential equations. So each time we go one up in whatever we're doing, that's one to the power of the variable that we're going to have. Anyway, so now let's solve it. It's r squared minus r minus 0.24 is equal to 0. Now at this point, I would probably just put it into the calculator, but something being daft, let's see if we can solve it. 100r squared minus 100r minus 24 is equal to 0. And we need something that's going to add to give us minus 100 times to give us minus 2400. 1640, but there will be minus, that give me a plus, so 12 and 2, so minus 120 and plus 20 would work. So I've got 100r squared, let's do plus 20r minus 120r minus 24 equals 0. Then we just need to factorise, so both got 20r in common with that one, so that'd be 5r plus 1 minus, these have got 24 in common, that's 5 lots, that's 5r, and that's plus 1. So 20r minus 24 times 5r plus 1. So we get our values of r. From solving this one, it's minus 0.2. And from solving this one, it's 24 over 20. 24 over 20, which is 12 over 10, which is 1.2. So we can say, therefore, Bn, so it's a, one of the solutions to a power, so 1.2 to the n, plus b times minus 0.2 to the n. So that's our general solution. However, we do have some initial conditions, V1 65, V2 71. That's going to allow us to solve for A and B. So let me just rewrite the equation there. and we had V1 was 65 and V2 is 71. So if I put V1 in, so that means I've got 65 is 1.2a minus 0.2b, and if I put in 71, that's V2, so that's 1 squared. I'm going to have 1.44a plus 0.04b. Well, to get from this one to that one, well, I've just times it by 0.2, so opposite would be divide, i.e. times. So if I times the second one by 5, then that's going to get us there. So if I times it by 5, 30 times 5 is 350, so that's 355. That's going to be 7.2. The way I'm doing it is I'm times it by 10 and halving it. And this one is going to be 0.2b. And then we've still got our one here, 65 is 1.2a minus 0.2b. Got, well, if I add them, then they're going to cancel. If I subtract them, they wouldn't, so I need to add both these equations together. So I've got 5, that'll give me 360, so that's 420. That's going to be 8.4a, and that's going to disappear. That's going to be 0. So I need to do 420 divided by 8.4, that'll give me a. So that will give me 50, because times it by, 500. Times it by 10 I get 84. Yes, 500 I think. I can just check it. Here, no, it's 50. Times by 10 gives me 84, yeah, I'm being daft. So that gives me an a value. That's what I've got a b is. So 65 is 1.2a, 1.2 times 50 is 60, minus 0.2b, so that means minus 5 is minus 0.2b, so that means b is going to be 25. Sometimes both by minus 5, and I can check it here, minus, so I made a mistake there. If I take away 60, I get plus 5, so yeah, it is minus 25, and a good thing this is a short question, I need to check. So my values, say therefore Vn is 50, 1.2 to the n, minus 25, minus 0.2 to the n. Make sure to remember that minus in the bracket, most people end up forgetting that because of the minus of the coefficient. So in part C, what if we, I should read it, that would help. So the model predicts the number of visits to our website will exceed 1 million when we've got this number n, and it wants us to find what this number n is going to be. So we want to find the value such that Vn exceeds 1 million, or 10 to the 6. So I've got 50 times 1.2 to the n minus 25 minus 0.2 to the n is going to be greater than 1 million. So I could try logs, but it's not going to work because I've got this minus thing and I can't separate a log over a minus sign. Now you could try and tabulate some values to get a rough sense of where they'd be, but this 0.2 here is going to be very small as n gets bigger, so that contribution isn't going to be much. So we can kind of sort of ballpark it by assuming that this term isn't there. So let's look at 50 times 1.2 to the power n. Right, it should be big n, shouldn't it? Because that's the value we're trying to find. Is bigger than 10 to the 6. And then we need to solve this. So divide by 50. And then take logs. So n log 1.2 is log 10 to the 6 over 50. So we can find that n has to be greater than log 10 to the 6 over 50 all over log 1.2. So to do that we need to get the value for that. Okay, so that will give me n is greater than 54.3. So I would read that as n has to be at least 55. But let's actually check it, because this was an approximation. Okay, so 50 times 1.2 to the power 55 minus 25 to the minus 0.2 to the power 55. And I'm going to take away 10 to the 6, and then I can see where it's positive. That'll tell me if we've got the right value. 1.2 to the 55 minus 25. Remember that minus in that bracket. 55 minus 10 to the 6. And that does give me a positive value. So I'll get 13224.1129. This is after taking away the 10 to the 6. So that works. Let's just check, however. Let's do it at 54. And if I do it at 54, I do get a negative value for this thing here where I subtract them. So the correct value is that n is going to be 55. That works.